Okay, I think we left off on page 117 and problem number 28. So it says the area of the rectangle ABCD is 40 inches squared. What is the area of unshaded region? So what do you think? Got any ideas?
Might be easier if they gave us length and width.
The shaded area is here, right?
Mm-hmm.
And then the area they've given us as 40 inches squared. So if you consider this a height, and then you consider this length A, B, C, and D, each one of those lengths like that. So then that first triangle is 1/2 of the base times the height, right? And the second triangle is 1/2 of its base times h. And then the next one is 1/2 C times H. D times H. Okay, that has a common factor of 1/2 H, right? Let's this right here is that times this whole thing, right? And that's given to us as what? 40 inches squared. So then it's 1/2 of that. 20 inches squared. The area of a rectangle is the base for the, you can, this is base times that height right there. But the base is A plus B plus C plus D.
Right.
And that's given to us as 40. All right. Let's look at 32. It says use dimensional analysis to perform each of the following conversions where answers are approximate, round to the nearest hundredth. So A is what, 0.25 miles squared, and they want it in feet, right? So what are you gonna do?
Convert the mile to feet.
So it's 5,280 feet squared in 1 mile squared, right? So then it's 0.25 times 5,280 squared. That's it. 0.25, right? Times squared. So 69, whatever that is. 69696 and 2 zeros. Nine, 6, and then there were 2 zeros, but your decimal place has to come back here, right? Because of this. So that's feet squared.
Is that right? Will it just be feet now? Because you squared the
Well,
mile.
see, it's in square, it's in miles squared, so you got to have feet squared. It's 0.25 miles squared. It's 2,000 meters squared, and they want it in centimeters. So what is it, 100 centimeters is a meter. So if you go squared, then you got 100 centimeters squared. This has got to be squared. So you're going to, what are you going to go? 4 places, 2, 4. 20,000.
Professor, I think you went to problem to 31.
I go 30. Oh, I did 31. Sorry, I did one of yours. So the C part. So this is there's 248 centimeters squared. They want to go to yards squared. So we got to convert. There's 2.54 centimeters per inch, isn't it?
Mm-hmm.
So inches, 1 inch squared is 2.54 centimeters squared. And then we have inches, so we got to go 36 inches in a yard. So 1 yard squared, and there's inches. There's what, 36 inches in a yard, so we got to square that. So I gotta divide that by 254, and then divide that 254 squared and then 36 squared. What's this? 248. Four squared divided by 36 squared. That's 0.0297. And that's yard squared. Just remember that don't just divide it by like 2.54 and 36, but you got to square those things. All right. 34. It says find the area of the triangle shown in square meters and then square inches. So that area is 1/2 of the base times the height. Seven 0.5 times 8.7, 8.7. And this is centimeters squared, right? And then we want to square meters. So there's 1 meter is 100 centimeters, isn't it? Okay, so we go 0.5 times 7.5 times, that was 8.7, I think. Divide that by 100 squared. Divided by 100 squared. It's like 0, 3, I guess 3. Meters squared. Now they want that thing, the B part, down to the nearest 100. Okay, 100,000 square inches. So what? What we do is go back to that centimeters, because our conversion is 1 inch is 2.57 so we get 1/2 7.5 times 8.7, and this is centimeters squared. Then we have 1 inch squared is 2.54 centimeters squared. That's divided by 2.54 squared. So that's 5. They said round to the nearest tens, hundreds, thousands, tens of thousands. That's 8, 9, isn't it? That's 5.0 because it's 0 is tens, 5 is hundreds, 6 is thousands, 8 is tens of thousands, the other 8 is hundreds of thousands. So it's 5.05689. I can remember. And that's inches. Okay. 36. So you have those two circles. I think that hurts. And it says one is 3 centimeters. So radius. So from here, so that's 3 centimeters. And then this one is 1 centimeter, right? Small coin rolls around the circumference of the fixed larger coin until the smaller coin returns to its original position. How many revolutions has the small coin made? So how are you going to figure that? It's 36. Any ideas?
First, you need to find circumference.
Circumference of the larger one?
Mm-hmm.
And that's pi times the diameter. So in that particular case, it's pi times 6 pi. And then the circumference of the smaller one is pi, isn't it? Now what do you do?
Diameter is going to be 2.
Hmm?
Radius is 1.
Oh, 2. Thanks. So then what are you going to do? could divide C, it's small, into the large, right? 6 pi over 2 pi, and that says 3, right? So it rolls 3 times. Let's see. How many revolutions? 3 revolutions. .38 says the area of a polygon drawn on square lattice or geoboard can be found using Pick's theorem, which states that if I represents a number of interior lattice points and B represents a number of border lattice points, then the area A of the polygon is given by A is equal to interior plus the border divided by 2 minus 1. And then they said refer back to column 13. So A is 13A. So the area, the interior points on A are what? On page 116, column 13A. How many interior points are there? Is there 0 interior points? And then how many points on the around the outside? How many points on the outside? 4, 8, 12, 16 points, isn't there? They're on page 116, 13A. There's 16, isn't there? Over 2, and then it's minus 1. So that's 7. And it doesn't, I guess it's 7 square units. So then what is 13B then? How many interior points are there? 6. There's 6, right? How many on the border? 13, 14, and then minus 1, right? 6 plus 7 minus 1. 12, right? There is 14 around the outside, huh?
Actually, there's 13 points. 13.
What?
So there's 13.
Yeah. So this would be 6.5. So that's 11.5. 13C. So how many interior points there? did you say 5? How many on the, how many on the thing? 16. Divide that by 2, and then minus 1. So we got 12. Then the B part there is saying Oklahoma. So the area there, the interior, how many? That's is 45 correct? And 30 on the border over 2 minus 1. $59. So okay, I'm not going to look at 40. Look at application problems, 42. One of the world's largest easy for me to say. Anyway, atom smashers is at the Fermi National Accelerator Laboratory in Illinois. The accelerator is in a circular underground tunnel 2 kilometers in diameter. Find the distance the atomic particles travel in one pass through the tunnel around to the nearest meter. So what are you going to do? It's a circumference problem, isn't it? And that's pi times the diameter. So it's pi times 2 kilometers. But now what do they want? They want it in meters, right? So what do we have to do? 1 meter what is the equality of 1 kilometer is 1,000 meters, is that right? So if I'm going to convert then it's 1 meter equals 1,000th kilometer, right? So this is 1 over 1,000 kilometers. So I'm actually going to do what? Multiply by 1,000. So it's 2,000 pi meters. Okay. 44. It says, according to the directions on a 20-pound bag of fertilizer / weed killer, one bag will cover 5,000 feet squared of a lawn. If a house, driveway, and lot have dimensions as shown in the following diagram, will one bag be enough? It says, assume that the unshaded region is to be fertilized. So what are you going to do? What's the strategy?
Well, first get the area of the whole rectangle and deduct the area of the house.
Okay. The shaded area, so the area that we're going to be involved with is going to be 65 times 110. And all these numbers in feet, so we don't have to worry about, except that one at the bottom, it says 12, no, it says 12 feet. So all of them are in feet. And what are we going to do? $65, 110, 45, 26, 35, and 12. And this is the part we gotta take out.
Subtract 45 by 26 and then 35 by 12.
Okay, so you're finding the area of this part right up here, right? Subtracting it out, and then you're going to find the area of this part right here, subtract it out. Okay. So it's 45 times 26, and then we can subtract again, right? 35 times 12. Now, if we want to do this all at once, what would we do next? That's going to be in feet squared. The bag covers 5,000 feet squared, don't it? So if we divided this by 5,000 feet squared, we'd have the answer, wouldn't we? This would be bags. So we could just do the whole thing all at once.
One bag would be enough.
Let's look. So we would have 65 times 110 minus, I gotta put a bracket around that thing. Okay, I have it incorrect. And we did 45 times 26, right? And I subtracted n, 35 times 12, and I have to close my bracket and divide by 5,000. So I didn't multiply. Crap. Let's go up here. Oh. Now I lost everything. I'm gonna have to do that whole thing again. Second. I just lock this thing up. Oh, I got it back. No. That to go down. Now insert division. All right. All that effort. So one bag covered. It won't, will it? It's 1.112. Where is the, what did they do away with it?
Something's wrong, Professor. Now, my calculation showing egg is going to be enough.
Did you do 65 times 100? Did you put a bracket around there?
I did them all individually. I got the whole area of the whole plot of land and deducted the house.
This is the right answer. What I'm hating is I lost my hope I didn't lose this. I lost that. Wait. I don't know why I lost that. It's still recording. But anyway, the answer is 44 was 1.112 bags of fertilizer. Okay, we can go back here. We can go up here and enter that down. Delete this out. That should be the area. that's the area, because that's this 65 times 110 minus 45.
65 times 110 is the whole area of the whole plot.
Yeah,
I deduct the house in two separate pieces.
Yeah.
26 times 45 is 1170. And then the other small piece, 35 times 12 is 420. 1170 and 420 equals 1590. 1590 from 6,500 is less than $5,000. So 5,000, one bag will cover that. You should have some left over.
well, I mean, you see that the calculations.
I see that, but
Okay, we'll do 65 times 110.
So,
right. My mistake. He's right. I did 100, not 100.
There's 7110, 7150 is the big area of the big part. Is that what you got?
He's right. I made a mistake. Ricky took mistakes.
What did you get for the area of the big piece?
50.
Okay,
He saw me make a mistake before I did. Good man.
okay, 40,
I
46.
apologize.
That's all right. We got it. It says a mason laying tile on 3 walls surrounding a shower. 2 of the walls to be tiled are 4 feet wide and one wall is 3 feet wide. If tile will be extended 7 feet up each wall, approximately how many 4-inch by 4-inch tiles will be needed? So the area that's going to be covered is there's with tile. There's 2 areas that are 4 by 7s, right? And there's 1 area that's a 3 by 7. And when you multiply that, that's going to be feet squared. And then 4 by 4 tile. So 4 inches is 1/3 of a foot, isn't it? So if you go 4 inches by 4 inches, you got 1/3 of a foot times 1/3 of a foot, which should be 1/9 of a foot. Foot squared. Right. So we're going to have to divide this by 1/9 foot squared. And what that's going to be then, the foot's going to be in the denominator. You're going to have 2 times 4 times 7, 3 times 7, and then you're going to have 1/9, and then this is actually foot squared per tile. So your answer is going to be tiles. 9. So it's 2 times 4 times 7 times plus 3 times 7 times 9 tiles. Oops. Put a bracket. 2 times 4 times 7 plus 3 times 7, close the bracket, times 9 693 tile. Okay, that's as many problems as I'm gonna do in this section. We're gonna go to the next section. There's a few more that are kind of interesting application problems. We'll start on section 3.2 the next time.